Hey, in my first video, I want to talk about this super important formula called the ultimate triangle method. So this method not only helps us to solve questions on length of projection, but it also helps us to solve other questions in vector lines and in vector planes. So this is how the triangle looks like. In our triangle, there are two vectors that you need to find, vectors A and B. Vector A is a vector that's elevated upwards and rightwards, which is usually denoted as vector AB. Whereas vector B is our direction vector of our horizontal line AF. So once you found these two vectors, we are able to solve for three different questions, namely length of projection, shortest distance, and our projection vector. So the length of projection is the horizontal length of our triangle, which is the modulus of AF. To find length of projection, we have to apply the formula modulus A dot B hat. So note that in this formula, there is a unit vector B hat. So we need to recall our unit vector formula. To find A hat, the unit vector of A, we simply need to take the vector itself and divide by the magnitude of A. And that's how you can find unit vectors. Now, applying the unit vector into our length of projection formula, we can expand this out to give us modulus of A dot B over modulus of B. So that's what you can use to help us find length of projection. So now, shortest distance. The shortest distance of our triangle can be denoted as modulus of BF. Now, if I want to find the shortest distance, I just have to apply the formula modulus A cross B hat. So for length of projection is our dot to find our modulus AF. Whereas for our shortest distance, which is the vertical length, we need to use cross. So that's the difference between length of projection and shortest distance. Now, expanding this formula will give us modulus A cross B over modulus of B. Lastly, projection vector. Now, many students may not understand what the projection vector is, but essentially, you can think of projection vector as giving the length of projection a vector. So if our length of projection is the modulus of AF, then our projection vector is just the vector AF. So to find our projection vector, we just need to use the formula of our length of projection, which is A dot B hat, and we add the unit vector of B behind it. Notice that in this formula, there is no magnitude anymore. It's a round bracket. So the reason why this is a round bracket is because projection vector is a vector, and vectors have both magnitude and direction. That's why you omit the modulus sign. So if I want to expand this formula, A dot B hat is the same as A dot B over the modulus of B, then B over the modulus of B. And if I put all the coefficients together, it will give me A dot B over the modulus of B squared and B. So these are the three formulas that you can derive by using the ultimate triangle method. So now I'm going to use an example to show you how we can apply these formulas to a question. We want to find the projection vector AF, but in order for me to find the projection vector, I will need my triangle in order for me to apply the ultimate triangle method. That means that I will need to connect the dots of A and B such that I form my triangle. Now I need to ensure that I have both my vectors A and B. So it seems like in this question, I have my vector B because 101 is the direction vector of our horizontal line AF. Next, I will need to find vector A, but currently I do not have that. So for me to find vector A, I need to find the vector of AB. So AB is OB minus OA. So I take the coordinates of both these vectors. So I take 3, 2, 0, I minus away 2, 1, 0, and this will give me 1, 1, 0. So now I found my vector A, and I place it in my diagram above. Now that I have both vectors A and B, I can find the projection vector. So the projection vector AF, applying the formula, which is A dot B hat, okay, I can expand this to A dot B over the modulus of B squared, B. Now plugging in the values of A and B, I have 110.101 over the modulus of 101 squared, and I add a 101 at the back. Now, evaluating the numerator, it will give me 1 plus 0 over the square root of 1 squared plus 1 squared, and I square it, and I add a 101 at the back. Now, evaluating the coefficient in front will give me 1 over 2, 101. So that is how you find the projection vector using our ultimate triangle method. So I hope you found this video useful. Thank you and see you again soon.